I would like to start our PtX Lab Talk 17. Hello, everybody on the screen, inside and outside our PtX Lab. We are very happy to present our policy briefing on securing critical raw materials today to the public, to you. And for this date, we have our PtX Lab Lausitz talk number 17 initiated. And I would like to set the frame for our discussions in the next 90 minutes. And it's about critical raw materials, which are becoming more and more in our focus. A bit late, maybe, for one and other people, but at least. And I will start with a little mini poll or survey. So let's go to the second slide. You see here a picture, a colorful picture, and it's a copper mine, of course, because of the color. And I would like, in the beginning of our webinar, to address two questions to you as our audience. And the annual copper demand in the European Union sums up to 4 million tons. And I would like to ask you, what do you think? What is the share of this demand of recycled material that goes back into the production? And what is the share of imports that are necessary to cover our demand? So if you want, I would like to encourage now to type into the chat a capital I for the share of imports, and then the percentage number, and a capital R for recycled materials that cover our copper demand in the European Union. So you may do this now, and I will check the chat for your answers. And while I'm doing this, wait a minute. Where's my chat function? Here it is. And while I'm doing this, or while you are doing this, if you want to type in two numbers for recycled share and imports share, I want to introduce our four experts just for a brief introduction here. We have Ludivine Wouters from Brussels Consultancy. We have Dr. Tom Lorenz from Research Institute DLR Aerospace, German Aerospace. And we have Sophie and Lorenzo from our PtX Lab Lausitz team. They will present our policy briefing. Okay. Okay, there's not too many answers in the chat. Imports 90%, imports 80%. Okay, Ludivine is import 60, recycled 10 and 15. Okay, thank you for your participation. I will give you the solutions. With the copper demand for the European Union, the imports share is 30%. That includes processed copper concentrates and also refined copper. So 30% imports and 50% is from recycled materials. And then there are 20% left to the 100, and 20% of annual copper demand consumption in the EU is evidently extracted and processed within the inside the EU. And that, just to have you taken this in mind, this is a very comfortable situation when we compare it to other critical raw materials. And we will see this in a short moment. So to have you now drawn a little bit into the subject, I would like to continue with the slides. So now here are the housekeeping rules. You are very familiar, I guess. Everything is in the chat, your questions, your comments, if you have problems, you can enable the closed captions. The slides of the presentations will be shared. This webinar is recorded already. And please do not unmute yourself. And also very briefly, a short introduction, the PtX Lab Lausitz, PtX Power to X stands actually for fuels and basic materials from green electricity and green hydrogen. We were founded 5 years ago. We are not a standalone institute. We are a business unit within the company Zukunft Umwelt Gesellschaft, which is federal owned. And we have now, luckily, almost 50 members in our team. And to sum it up here, our task is basically everything that is surrounded of the subject PtX, market ramp up. We are the platform for industry, politics, and science. And we should take the lead. That is our task from the government in every aspect to enable a sustainable PtX ramp up. Okay, so now I look at the, okay, we are in time. I'm very happy to start the inputs, the talks of our 4 experts. And I want to give you a short biography of them. I shortened it a bit. So first of all, I would like to introduce to you Ludovine Wouters. Ludovine, I hope I pronounced your last name correct. Sorry if not. She is managing partner of Latitude 5, an advisory firm in Brussels. She's focusing on mining and minerals and has expertise in gross transactions, regulatory affairs, government relations, and permitting. She's also a director of Euro Manganese. And as I may add, I know she's very active in bringing together stakeholders from national parliaments, EU representatives, and from industry to initiate discussions and boost actions for a functional internal raw materials market. And now I come to Dr. Tom Lorenz. He joined German Aerospace Center and the Institute of Low Carbon Industrial Processes in Cottbus in 2020. He has also a PhD from TU Bergakademie in Freiberg. And he established at the German Aerospace Center the Department for Simulation, not Simulation, Simulation and Virtual Design, and he's now co-head. He works on recycling processes and sustainable product designs. And actually, he will show us in a minute a premiere, I guess, as I understood, results of a project called MARTIC-M, Methods and Technologies for an Intelligent Circularity of Materials, that is surrounded on the subject enhancing circularity and recycling quota, which is indeed very important. And last but not least, we have my colleagues, Dr. Lorenzo Cremonese. He works in the section of the PtX Lab Lausitz Basic Materials, and there he focuses on critical raw materials and their connections to PtX products and technologies. And we have Sophie Kamrat. She's in the team of PtX Policy and Market Ramp-Up, where she leads a project investigating the connection of the EU concept of open strategic autonomy with the field of Power-to-X technologies. And Sophie, Lorenzo, and me, we worked on this policy briefing on critical raw materials. And okay, I think my name is in the picture. All right, so now I'm very happy to end my introduction to you all, and I want to hand over to the first speaker, Ludovine, please.
Thank you, Anja. I am going to share a few slides. Can you see my slides? Yes, excellent. Well, first of all, hello to everybody who's joined. I want to start by thanking PtX Lab because they are obviously practicing what we need most at the moment, which is the very complex and sometimes uncomfortable conversation across value chains, across industries, across disciplines. And this takes time, it takes effort, and I'm particularly grateful to PtX Lab for enabling this conversation today. So let me give you just a very short overview of what I think is the key aspects of the critical minerals agenda, the landscape. I only have a few slides. The idea is to really help us think through what our colleagues are going to be discussing shortly. This is a busy slide, and to be honest, it's partly voluntary to illustrate a little bit how complex it is to position the minerals conversation in a very busy European timeline of evolution. So the CRM Act was adopted in April 2024. You will remember that this is really at the end of a policy cycle. So every time we complain about the shortcomings, the limitations of the CRM Act, I think it's worth remembering that it was adopted at a time when, the Commission had very little left in the tank in terms of political capital. It was a turning point. It happened also really at a time when European priorities were completely overhauled. Strategic autonomy, climate ambitions. Suddenly we were adding to this mix, regional and economic security concerns. So the CRM Act, I think, is a manifestation of huge political transition and the fact that the EU is rediscovering industrial policy. Let's not forget that for the last 30 years, the words industrial policy have been something that is, was not well perceived. The European principle was free markets and open trade. And so everything that has to do with how we integrate the foundations and the competitiveness of industry is something that is a new mandate for the European institutions. Again, this is to contextualize why we see significant weakness, but also weakness that needs to evolve as this transition continues. I want to spotlight a couple of things. The slides will be available. They're full of links if you are so inclined. So about 18 months after the CRM Act was adopted, you will remember that in the last quarter of 2025, there were a series of acknowledgements of a change of paradigm. President von der Leyen in the State of the European Union in September, then in various speeches, particularly one at the Berlin Global Dialogue in October, really highlighted the fact that this was not business as usual and we needed to rethink. And so a few weeks later, the Resource EU Action Plan was announced as, a big jump forward, a bold move to really advance the CRM agenda beyond what had been done to date with strategic partnerships, strategic projects, but frankly, not a lot of outcomes. What we got instead was, much of the same. Resource EU is not a bold move forward. It's actually repackaging of existing strategies. What it did contribute, and I think this will link to some of the things that my colleagues will explain or discuss later, is that we were working in the CRM Act under a huge list of 34 critical minerals, 17 of which are strategic. The Resource EU Action Plan really refocused around 3 priority value chains: permanent magnets, batteries, and defense. Already, we have a fine-tuning of strategic priorities. But the fact is, Resource EU does not address key weaknesses in political ownership, institutional accountability, which has been a recurring issue with the CRM agenda. And it also doesn't deliver on some of the missing foundations, including mineral funding for mineral priorities, which does not exist at EU level and is extremely fragmented among member states. So that is a bit of a missed opportunity for reset. But to be honest, the great thing with policy is that when there is a missed opportunity, it gives you a great space for accountability, which is what we've been focusing on. The second thing I would just highlight is that across this entire evolution since the last elections, EU defense is something that has not only risen to the top of the institutional agenda, But it's also been part of a wide conversation about priorities. There is a debate about the trade-off between defense expenditure, welfare spending. There is a question of industrial transformation and reindustrialization, which could link both to the transition goals, which remain a primary priority for the EU, but also industrial transformation to enhance military capabilities. All of this means that we are dealing with a lot of complex issues, and it takes time. It is frustrating, don't get me wrong. I have no patience whatsoever, so I wish we could make the right decisions quickly. But it's worth remembering the complexity of what we're trying to address. And last point I want to flag is the Industrial Accelerator Act, because it was finally announced in March 2025 after several delays. And the idea is really to push forward the clean industrial deal and to implement the principles of the economic security strategy. You will remember that the economic security strategy was updated on the same day as Resource EU was announced. I think it is an overlooked tool to really push for change. So if we have time, I'm sure we can discuss it some more. The Industrial Accelerator Act is going to make a lot of noise because it's going to once again epitomize some of our internal conflicts and debates about, made in EU, made with EU. Are we an open economy? Does resilience, does security of supply, does, economic leverage overtake the usual views that we have on best prices, most efficient supply chains? All of this debate is going to continue through the IAA. And I would encourage you, as you read all of this commentary and get involved in it, not to get too over-focused on made in and made with EU. The rest of the IAA is also important to pay attention to, because the measures that are going to focus on the strategic sectors are going to have value chain implications, if only because we need locomotives to drive demand to really make the CRM agenda an industrial reality, which at the moment, I have to be honest, it's not really in the EU. So this is a confused background. And then what happened is we had a very stark reality check. If you haven't read this report, I would absolutely urge you to read it. I would also recommend you read the European Court of Auditors report on the Innovation Fund, which will make your eyes pop. The reason this is important is that we shouldn't confuse the European Court of Auditors with a policy shaper. The European Court of Auditors is really an independent controller of EU initiatives. It aims to improve governance, accountability, and financial management. But what's interesting is that as we were going through this evolution of policy that's less and less on you can do this, but you can't do that, and that's more and more on how do we set goals together, then the voice of the ECA adds also to this goal setting and to how we're progressing on these goals. And I think that's important. I'm not going to lie to you. It's a sobering read because it highlights some of the weaknesses we've already raised. There is a lack of accountability of the Commission on this agenda. There is significant confusion. I think it's easy to blame the Commission. The member states themselves add to the confusion with disparate and miscoordinated national initiatives, but also they add to the lack of accountability because there's not enough political leadership from the member states on this agenda to really get the Commission, well, to be the best version of itself. So I think that, again, as things progress, we need to watch all of these policy shapers and how they interact. Some of the other points that were clearly raised is the lack of value chain understanding, the lack of vision. Effectively, the ECA concludes that the Commission is flying blind on minerals. They're constrained by outdated institutional models. They don't have a lot of political capital for this agenda. And frankly, they are lacking, not just the Commission, a lot of member states on the technical expertise. And when I say technical expertise, the difficulty is that when you deal with minerals, much like other evolving sectors, you need to be able to understand the basics of an engineering issue all the way to finance and how does money flow. And the difficulty is that by not realizing that these are essential questions, we sort of keep going back to very weak initiatives. As I said, the ECA also spotlights the fact that the European agenda is not backed by money, that this is a foundational weakness. This is something that is evolving, and it's probably where the ECA report has started to have impact, because following the leadership of some MEPs, and of course MEP Hildegard Bentele of the EPP group has been at the forefront of this, but others have now accepted the principle that unless Europe very clearly puts its money where its mouth is on minerals, we will continue to go in circles. So there is something bubbling. We need to see how we're going to realize that. And I think where there's a missed opportunity is the fact that whether it's the CRM Act or Resource EU or the Commission's initiatives, even the member states, there's an over-focus on the internal aspects of this agenda. And I understand why, because that's what they govern, that's what they regulate. But the reality is that, and as the ECA point out, Europe will remain dependent on the rest of the world for a long time on minerals, and will always be, because at the moment, imports are the core of mineral supply. So over-focusing on the internal aspects without realizing that we need to be working on resilience of supply with global partners in a much more effective way. Strategic partnerships that are empty MOUs fool no one. They are just that, empty promises. Unless we refocus energy on that, we may be working on a long-term solution, but the short-term issues will prohibit us from getting to the long-term.
Ludivine,
Yes.
may I just remind you, you have to come to the end of your presentation, because we have also time for the discussion at the last part of this webinar.
Yes, thank you very much, Anja. So this is my last slide, and it is again a bit busy because I wanted to just open up the conversation on what are we actually dealing with at the moment. So there is, we all know, a context of global and regional tension. There's an energy and economic crisis to contend with. But in that context, what is Europe going to decide? And I think the complexity is that minerals are relevant across all of these issues, but simultaneously, minerals are an issue in and of itself. So we are at a crossroads. We need now to overcome the incoherence among member states. We need to overcome the lack of vision from the Commission, which reflects the mandate it's given by member states. And frankly, we need to have a framework, a matrix of thinking that integrates short, medium, and long-term action with a clear understanding of what needs to be done today, particularly diversify mineral supply through international relationships, because that is where the supply comes from and will continue to come from for a long time. Simultaneously consider the long term. Of course, we can reduce dependencies in the long term through development in the EU, through recycling, through much better resource management in industry. But unless we take care of the short term, we may not even get to the long term. And my last comment would be the following. We systematically focus on our weaknesses, and I have done that in this presentation, so I'm guilty. But we need to remember that maintaining and bolstering European strengths in international trade, in infrastructure, in processing capacity, in skills, these are the levers of strategic autonomy and economic leverage. So we need to remember to play to our strengths in minerals as in every other sector.
Wow.
Thank you, Anja.
Thank you so much also to give us a vision that is obviously lacking in Brussels at the political side. And now I'm very happy that we have Dr. Tom Lorenz, and we are curious about what you will show us.
Thank you. Then I will take over, and it's really good because I start from let me see. Yeah. Hopefully you can see my screen. Please tell me if that's the case. Anya, is it to be seen or not?
Yes, it's to be seen, but it's not in the presentation mode yet. We see the
Okay.
next slide already. Maybe
Maybe that's the wrong yeah. Then let me stop and give it another try. That's the wrong screen then. Now it should work.
Now it's perfect. Thank you.
Perfect. And I will start. Yeah, I will show a little bit about a project that we finished recently that is addressing the part with securing strategic raw materials through sustainable product designs. And before I will connect a little bit to what Ludovine already said. Yeah, we started in this project, of course, with the Critical Raw Materials Act that mentions a few of these goals. So till 2030, we want to secure the demand in the European Union for critical and strategic raw materials, and at least 25% of this demand should come out of recycling capacities. I'm hitting the point of strategic raw materials a bit in this regard because that is the materials we are talking specifically here, as they are crucially important for technologies related to energy transition, digitalization, defense, and aerospace. When you see some results on the right-hand side, so there's a lot, not just only magnets. Also, we have glass fiber cables, where we have germanium cables for electronics, also for catalysts for the SAFs. So there is a lot where we see these raw materials, not always in high concentrations, but they are essential to the functionality. Plus, we also see that the future supply of these strategic raw materials is not guaranteed because of a rising demand, limited resources within the EU, and the problem that production volumes are difficult to increase, which is often to the very fact that these strategic raw materials are only byproducts of mass metals like aluminum or copper. So I want to shed light on two major things here with regard to strategic raw materials. They might appear only in small amounts when you compare to the amount to the mass of a product, but nevertheless they show really high CO2 footprints. Yeah, the pink bars here show the strategic raw materials, and in the little box in the middle you see a comparison to iron, aluminum, and the like. So, and the unit is tons of CO2 equivalent per ton of metal here in this regard. So strategic raw materials are really extensive when you want to mine them and to process them, in contrast to the mass metals. A second point I want to shed light on is the global recycling quota. So you see, okay, rhodium, platinum, palladium at the very top, and they have good recycling quota, let's say, with above 50%. But then we have also a large group of strategic raw materials, 12 of them in number, that have global recycling rates below 1%. And here we see resources like gallium for semiconductors, the rare earths for permanent magnets, or lithium for the batteries. How is that now connected to the sustainable design? We see in the second circular economy action plan, which is also a part of the European Green Deal, there is mentioned that 80% of a product's environmental impact originates from design phase. And there is also mentioned what we need to, or what we want to expect from sustainable products, which is we want to have low CO2 footprints, we want to have high energy and resource efficiency, repairability, recyclability, and the like. When you have such high expectations of a product, it's really difficult to fulfill that. So that's really a challenge. And there are a lot of challenges attached to this. let's say, wish to have that, I will stick to three main challenges here. At first, when you think about a product designer that constructs a product in his or her computer-aided design software, so CAD software, you have to say there are, in general, no recycling experts. They can make decisions, but it's complicated to see which is the right one. So the second point is a limited data availability, and that applies to the product itself. When you think of complex products, you have a chain of suppliers that produce components of a product, and complex in this regard means washing machine and the like already. And we see that often the company, the OEM, does not have the data of all the components of that the product consists of. And the same with data availability also applies to recycling processes, as they are in general treated confidential by the recycling companies. And so forth, it's also difficult in order to have the data availability to take this data into account for a product design. And last but not least, we do not see a uniform methodology of how to develop sustainable products. And that is where we started from. We asked the question, how can sustainable products designs be achieved? So, and the project Matic M started in 2023, and the duration was to end of 25. And we tried to address the stakeholder demands of the industry. The industry wants to have more resilient supply chains by incorporating secondary raw materials, so material that originates from a waste treatment. But on the other hand, and when you want to have a more in this regard, you need to come up with higher quality of secondary raw materials from end of life products. And that's not something you get for free. You have to do something to have that. And the second stakeholder demand is, of course, society and politics. We want to battle climate change still, and we want to mitigate the supply risks, specifically for these strategic raw materials. So for the Matic M project, we defined our main goal that we want to create a design for circularity software. And this software in particular is meant for assisting a product developer in developing better recyclable products. And we want to see, of course, products that maximize recycling quota. We want to de-risk raw material supply that pays attention to strategic raw materials, but we also want to see low CO2 footprints, and also all of the production still has to be economic. So there's hard goals to achieve here. In the project itself, where 13 DLR institutes were involved, we started with a concept idea, and the task was make a software out of this idea and test it on use cases where DLR is a product developer on its own. And there were an electric motor, a sidewall of a plane, and an actuator of a solar power plant that was that served as use cases. I will show a little video in a minute that shows how a product designer could interact with the software. But at first, I want to shed light on the design criteria. A product designer also already has to take many things into account. So you cannot overwhelm a product designer with a new large set of design criteria he should also pay attention to. And so you should limit the number. The second thing you should also do is to make sure that these criteria are comparable. In this regard, we've chosen 4. So we stick to emissions, which is the CO2 footprint that is calculated according to the same ISO standards like in LCA, so life cycle assessments. We had costs, we had criticality, where we took it from the Critical Raw Materials Act, so the same method of evaluation. We just extended it a bit because here we want to evaluate technologies and not just one material. And last but not least, circularity according to the indicator provided by the Ellen MacArthur Foundation. So that takes into account the recycled material in the product, as well as how good it is recyclable. Last but not least, there are 4 criteria, and you often have the case that when you make a decision, one criteria improves and maybe another decreases. And so it makes it harder for the product designer in the end to really see, is this a good choice or not? Therefore, we have the DFC score. And this score is just a summary of these 4 criteria, plus a little option to prioritize, because okay, the product designer, so the company could decide, is life cycle costs more important than the carbon footprint, or is it vice versa? So here we have a little point where you can have an extra influence. Okay, let's have a look. So the product designer has a CAD file, so a step file, and a bill of materials about the components and everything that he or she uses. And then he would use our upload it into our software. You see it here. On the right-hand side, you get suggestions with regard to the materials. So you could replace materials that could boost your DFC score, your recyclability, your criticality. You need to check that as a product designer if it's really a good choice. And you could adapt that right into the software. And then you see how these criteria change. Yeah. The also what is also interesting in this regard is that you can, of course, improve single criteria or the overall score, and you're also provided with more information about the recycling. So which secondary raw material output do you have? How good is which material recyclable? Or what is the expected recyclability per element? So also you get information about the disassembly sequence that sheds light on each component you have in there with regard to weight. If it is recyclable to one specific secondary raw material, of which materials does it consist of, also with regard to strategic materials, and so on. So that gives you a little bit more information and a basis you can use for your design decisions. So with that being said, I want to address one little point here. Within this design for circularity software, there was some effort spent on how we anticipate recycling paths before, because that is a complicated thing that you always have. Yeah, what is when you have a complex product consisting of many different materials, what can you expect here? So we have a little tool inside the DFC software called Ceramis that conducts a matching between each component the product consists of, and so each material, and conducts a matching through similarities with regard to form, shape, volume, chemical composition, and the like, with secondary raw materials that are traded on the market. And in this regard, it estimates recyclability and tries to maximize them for the product on the level of chemical elements. And the good thing here, what you can see is the main problem of products is not that you have strategic raw materials in it. The problem arises through what strategic raw materials that are in it are not recyclable. When it's good and you can recycle them within the European Union, that's fine. But you should shed the light specifically on where you have the problems. And that can be done here. So Ramis itself, there is a little example on the right-hand side for the electric engine, for instance. Yeah, an electric engine you would crush, you would shred into little bits and pieces, and then have it sorted during recycling process. But for instance, the Ramis suggests to disassemble 52 of these 133 parts instead of shredding them. And it gives you only a small improvement of recyclability of roughly 5%, where you could, through disassembling, recycle a little bit more material. But these 6.5 kilogram consists of 94% of strategic raw materials. And given the fact that they have high CO2 footprints and energy demands, this 5% represent 1/4 of the energy demand and CO2 footprint that was invested into producing the whole electric engine. So that is what you could win here potentially. Let's have a look at the results. So we optimized the designs that we own. So the original design of our electric engine, we had some recommended design changes, and at the end we could improve. We could lower the costs by roughly 1/3. We could save CO2 emissions 123 kilogram per electric engine, and also could improve criticality and circularity by a bit. But it's important to understand that this is really specific to the use cases. Yeah, that's lucky that we could do that. It looks a little bit different when you have different use cases, and that's of course that's expected to see. Yeah, for the actuator, for instance, there were smaller improvements as for the sidewall, which is almost completely composed of compound material and plastics. We see that you could uh, change the material, for instance, to bio-based material to save CO2, but that would ramp up costs. And now it's the decision of the company and the product designer if that is the choice you can take or not. So um, that brings me to the conclusion. So the design for circularity software is not a fully developed product yet. Yeah, it was developed within DLR. It's so technology readiness level 4. It was successfully tested on the used cases, and its development was supported by an industry advisory board. So you can see the companies, and many thanks to them on the right-hand side with their logos. With regard to the next steps, so the next steps would involve that we further develop this software to technology readiness level 6. That means we involve the industry directly. And we have two kinds of partners we are looking at, and we are communicating to that are companies that provide product designs that could be improved to validate that everything the DFC software predicts is correct and applicable to these product designs. Plus, of course, in future, DLR as a research organization won't be the provider. So we are talking to CAD software providers right now that are willing to further develop this software together with us. So last but not least, the DFC software is to be presented on this EFAT exhibition in May in Munich. So when you are already there, it's a world-leading exhibition for recycling and circular economies. You're very welcome to visit us in Hall A6 and at our booth 101, and you can give it a try on the DFC software in its current state. So with that being said, thank you for your attention. And if you're interested, um, reach out to me. Thank you. Mhm.
Thank you very much,
Mhm.
Tom, for this um, super insight of innovation in enhancing circularity and the recycling
Mhm.
shares of the strategic materials. Um, there was already a question, and although we have a Q&A session at the end, I just want to take
Mhm.
this. So is this free to download? This is a question I expected already. So how can, let me phrase it a little bit
Mhm.
differently. How can interested stakeholders, industries, companies already may benefit from the results you just showed?
I would say this thing is still under development. So the next step for us to take is, of course, to take it from that, so to further develop. And of course, you could contact us and also see, okay, when you are, let's say, when you have similar use cases that are similar to what we've already examined, it could be easier to extend the database to that, to have also an examination that fits the product, your product maybe, yeah. At the moment, of course, the database could not uh, cover all the varieties of metals and compound materials and plastics that are out there right now. So, but that is also a task we want to build up. So the database, we want to connect also with LCA databases and the like, so that we can incorporate as much data as possible. But that is a thing that we've started. But we are definitely not on the at the finish line right now.
Okay, thank you so much. And if there are further questions, you showed your contact and your name is out there, so you may get more inquiries the next days, maybe.
Thank you.
Okay,
Would
thank
be
you so
cool.
much.
Mhm.
Cool. All right, so now I'm happy that we proceed to my two colleagues, Lorenzo and Sophie. And Lorenzo already is sharing his screen, so the floor is yours, Lorenzo.
Thank you very much, Anya. I think you can see that clearly now. Okay, great. So first of all, I would like to thank the two previous speakers. I think they gave a very, very nice introduction to the event today, going from the policy side and what needs still to be done, a lot to be done, we heard, but also with a very positive note about our opportunities, and going to the point of how to improve circularity and recycling. That is also an important way to decrease our primary demand of resources. That said, let me also add that I'm very pleased today to have the opportunity to present our latest publication, our latest newborn at the PtX Lab Lausitz. That is the policy briefing on how to secure critical materials for green chemicals. As all of you know, the problem of a resource, in particular of minerals and metals, it's a very, very hot topic right now. And not only the policy level, but obviously also in the research area. And many publications been released lately, and many more will come. And our idea, the PtX Lab Lausitz, was to contribute to this discussion, and in particular to integrate also our knowledge in it, and to provide a clear and targeted recommendation on how to also ensure these mineral metals for Power-to-X technologies, as we believe that these are key technologies to defossilize and decarbonize three of the most important economic areas, sectors, that are the maritime, the aviation, and the chemical sector. This policy briefing is the result, is the outcome of a collaboration between two research groups at the PtX Lab Lausitz, the Basic Materials Group and the Policy and Market Ramp-Up Group. And what you're going to find in this policy briefing, that is from now on, as far as I know, from now on downloadable on our website. What you're going to find inside, it's in the discussion, it's partially the results of a previous study, the raw material demand and availability for net zero aviation, a study that we published last year in collaboration with DEGEMA. And the technical part of that of this policy brief, that is mainly going on the discussion on indicators and specific critical raw materials. It's, as I said, is a development of the results we showed already in this previous study. But this policy briefing goes also further and also spread on other topics like policies, financial mechanisms, and sustainable mining. This policy briefing is structured in 12 recommendations, and this recommendation also classed in three main groups that we named the tackling the demand side, sustainable and equitable mining, and power-to-liquid technologies, critical materials, and circularity. I will give an introduction. I will present the first four recommendations from the tackling the demand side part, while my colleague Sophie later on will give an insight on the latest three on the topic of technologies, critical materials, and circularity. So going to the first recommendation. So the first one goes around the idea of binding material reduction targets. These targets also are the measures on binding reduction have been largely neglecting the discussion on resources. That's what we believe. And although these actually reduce demand and would also alleviate supply side risks, and therefore ultimately strengthen the EU autonomy. At the EU level, reduction target reference, for example, in the Circular Economy Action Plan, do not include specific thresholds. They're also not binding targets. When we look more at worldwide level, Sustainable Development Goals set also vague reduction targets. And also, as you know, SDGs are not universally accepted and are also not binding. We believe that material demand reduction should be mainstreamed in policy debates, and that practical and specific reduction targets and also incentives should be set. How can we do that? When we look at which action are needed to tackle the demand side, we can think as, for example, setting short-term goals for material utilization. And here, additional research on the level of such short-term targets is necessary. For example, improving data availability in order really to understand which short terms are achievable by which time frame. Also introducing concepts like sufficiency in narratives and values when we relate to public and in the political discussion. And we also believe that agreement from at least the largest industrialized countries have to be taken, so have to be shared. So to summarize a bit this concept in our recommendation, what we state is that the EU should introduce binding and ambitious short-term material reduction targets already for 2030 and 2040, while worldwide global material demand should be set at 6 to 8 tons per capita until 2060. This is a recommendation that is in line with the United Nations Environmental Programme. Moving further with the second recommendation, that it's about the material footprint, the indicator, material footprint as a consumption benchmark indicator. The material footprint is a widely used material indicator to monitor natural resource utilizations. It basically measures the amount of material directly used in a product or a region, but it also accounts for other material that are needed in the value chain, what is called indirect flows. The material footprint can also be applied to products, and therefore this indicator has the potential to provide an important tool for comparison among production technologies, like, for example, power-to-liquid technologies. It is also one of the performance indicators for 2 SDGs and also for the Environmental Action Program. When we look at the national in Germany and the National Circular Economy Strategy published in 2024, the German government proposed a material footprint benchmark of also to 6 to 8 tons per capita for the year 2045. To give a little bit of context, today the worldwide average is 13. Germany is about a little bit about 15 tons per capita. But what is also important to state is that the current resource consumption in developed countries is not sustainable for the planet in the long term. So we really have to act on reducing this. We therefore strongly agree that improving and extending the utilization of a material footprint as a monitoring system, also together with other indicators, is needed. So also, when we look at decreasing this material footprint worldwide, it also appears that it's unlikely that when we look at, for example, the EU, but not only the EU, significantly reduce this material footprint without targeted action is going to be very challenging. That is why, to summarize, our recommendation states that the material footprint indicator should be internationally accepted as monitoring proxies for raw material utilization, both as an indicator for economy-wide, but also for product-based material flow analysis. And when we look at product-based, we also mean here power-to-liquid technologies. Going to the second indicator that we discussed in the policy briefing, it's the total material requirement as an overall environmental impact indicators. The TMR provides a good indication of their overall environmental impacts associated to goods manufacturing, also like material footprint for a specific region. Since it includes the material directly used, the indirect flow, exactly like the material footprint, but also add on it the unused material that has to be mobilized for the purpose. It is nowadays not widely used also in the literature, but has a strong potential as a benchmark to identify technology or production pathways that are best performing in terms of impact on the ground. Also here in the field of power-to-liquid technologies. Mining is, in fact, as you all know, a strong repercussion on local ecosystem like air, groundwater quality, biodiversity, and so on. But unfortunately, what we see with TMR, the database is still incomplete or not reflecting geological condition at all locations. And so the coefficient to calculate TMR are highly location specific. For this reason, the inventory still suffers from a certain degree of uncertainty. Moreover, what it's also we also need to be said about TMR is that the methodology for fitting the purpose has not been identified and should be identified before being implemented in policy regulations. Important also to say is that TMR and the material footprint complement each other very well, since these two indicators provide together a different set of information. They are not necessarily correlated. It is why our recommendation says that total material requirement indicator is well suited to assess the overall environmental impact of raw material production, and therefore should be also implemented in the regulations.
Lorenzo?
Yes.
You are running a little bit out of time, so maybe you can wrap it up a little bit. Sorry.
The last point is the supply risk management through criticality assessment methods to buffer the risk of resource supply shortages and therefore to ensure economic resilience. The European Commission defines, as you all know, every 3 years a list of critical materials under the Critical Raw Material Act. And this effort, we believe, is an effective, clear attempt to respond to future crises, but also to support the market dominance of countries like China. As you know, they're very strong in terms of extraction and processing. But nevertheless, several critics of the current CRMA have been raised, like we already seen, on several topics. And we believe that policymakers in the EU should also take into serious consideration these suggestions on how to improve these targets. The Resource EU Action Plan is also a good example, a follow-up, although also there we think is to be a little bit better target for the purpose. This policy brief thus encourages the further development of criticality assessment criteria, also by comparing methodologies for criticality assessment with other countries. Like, for example, in the report we name or we discuss briefly the material list, the critical material list from the US. So our recommendation states that up-to-date criticality assessment methods and also more granular targets are needed to ensure a long-term economic viability and resilience of green technologies. Thank you very much. I'm going to give you now the floor to my colleague, Sophie. So, Sophie, the floor is yours.
Yes, thank you so much, Lorenzo. I kind of want to circle back to Ludwig's point from the beginning on how the EU is trying to balance its commitment to climate objectives, but also industrialization at the same time. Because I think this kind of relates to the question of how we can actually make better use of what's already here in the EU. And for this, we need to look at the whole recycling chain for raw materials from collection, but also ultimately to the establishment of a trusted functioning secondary raw material market. And there's one waste stream that I want to highlight because it's just very relevant, I think, is the waste of electrical and electronic equipment, or e-waste, because it contains several highly valuable CRMs, including cobalt and platinum and iridium, which our previous study that Lorenzo mentioned found to be very critical for PTL production. But it's even of importance beyond our little niche PTX and for the general raw material policies. Because as you can see, 46% of e-waste in the EU is not collected separately. And that's what an EU staff working document from last year found. And they also found that the directive is not really effective in its form, the WE directive from the EU. And actually back in 2024, the EU Commission opened an infringement procedure against all member states across the board for failing to meet the waste collection and recycling targets, including for e-waste. So I think it's good and it's necessary that as part of the upcoming Circular Economy Act, which is expected in the 4th quarter of this year, the EU is expected to address how to make the WE directive more effective. And we believe that as part of this review and also the Circular Economy Act itself, it's really important to always pay particular attention to the recovery of CRMs that are necessary for the energy transition, of course, for PTL as well. And that should go along with the stock taking of how infrastructure collection and take-back systems based on extended producer responsibility can be strengthened. Because it's really critical to just leverage the potential of e-waste. It's the fastest growing waste stream in the world, and it can provide us with a lot of valuable CRMs if we manage to tap that. Of course, not only collection is important, but also kind of what comes after. And I think recycling is a key of that, of course, and there's a lot to be improved, as we've heard before as well. For example, 10 out of the 26 CRMs that are needed for the energy transition are not recycled at all in the EU, and 7 have a recycling rate between 1% and 5%. So there's really a lot of room for improvement. There's also the question of product and recycling design, but I think Tom talked a lot about it, so I think he explained it way better than I will. Just wanted to quickly mention the potential of closed loop recycling in industrial settings, because that's where PtX lies. So it's really important to look at how PtX technologies are integrated in the recovery and recycling chains and how they can be better integrated, because stacks from PEM electrolyzers, for instance, they provide a highly relevant source of platinum and iridium, but they are often difficult to recover without loss of value because they're just so integrated in the machinery and system. So I think what Tom is doing is a very, very relevant, of course, on that. And to make use of the CRM sources, the EU should, in the circular economy, take really stock of how these relevant frameworks need to be made fit for purpose of a circular economy, and then they should systematically consider these renewable energy and green hydrogen and PtX relevant technologies needs, but also the opportunities they provide. And of course, so keep the slide, sorry. Ultimately, I think the key is really to enhance the circularity for CRMs is the establishment of a functioning and trusted secondary raw material market. And that's a market that leverages the EU's strength of the single market. I think Ludivine also touched upon that in her presentation. And for that, we believe that clear and harmonized end-of-waste criteria are really crucial because they actually define under which circumstances a substance is no longer determined waste, but a secondary raw material that is ready for next use. And that just gives clarity to all market actors. And currently, only a handful of these materials, these end-of-waste criteria exist. So it's a necessary step to pay attention to relevant raw materials for that, for them. So here again, the upcoming Circular Economy Act is going to be central. A lot of faith in this act, if it's done properly. And now you can switch to the next slide, Lorenzo. Thank you so much. But even if we assume we have a great functioning secondary market, I think we still have to be realistic. There's still going to be delays in CRMs that are available for recycling just due to the long lifespan of products. Raw materials needed will still be subject to high competition of use. We will still need imports, also like Ludivine said, in short term. So I think it's really useful to see how we can make the most out of what is already here, but also take a broader look at how we can substitute these materials, maybe for materials that are more available or materials that are less critical. And the report by the Court of Auditors that Ludivine mentioned, great report, I also very much recommend it. They found a legislative gap for substitution in current EU legislation and national circularity plans in relation to substitution. And we think that's a very, very relevant point. And in our policy, we got a bit deeper into the research part of the substitution. So for PTL, for instance, current research explores how iridium and platinum used in water electrolyzers can be substituted. And there are several methods for that, like atomic dispersion, alloying, using nickel-based catalysts instead, magnetic fields, or transition metal phosphides and borides. And my technical colleagues can explain to you much better how that works. But of course, research needs to be supported, and for that, it needs funding. And that's why we think it's very crucial to feature R&D on substitution of energy transition CRMs even more prominently in relevant EU programs like Horizon Europe, Innovation Fund, IPCIs. And with the next MFF, like the EU long-term budget that is currently being negotiated, I think there's a window of opportunity to anchor this and to advance this and to strengthen the supply of raw materials in the EU and to strengthen its sovereignty. And I think I will leave it at that. I hope I'm still in time. Thank you so much for your attention. If you have any questions, please do. I think the link was already shared in the chat. Over to you, Anja.
Thank you so much, Sophie. Thank you, Lorenzo, for wrapping up our recommendations in the policy briefing. Before I come back to my prepared questions to the panelists, I have found one in the chat. So this goes to Tom Lorenz. Does the MATIC-M consider ecological boundaries, ecological footprint as well?
We at the beginning of this project, of course, we had a group within our project team that was figuring out or trying to figuring out what should be the criteria a product designer should take care of. And of course, we had also specialists that were really good in life cycle assessments and similar methods. But the thing would be you could extend this list, of course, anytime. So also to cover these criteria, but it would make the job for the product designer, of course, really difficult if you do so. So in principle, it would be possible to extend that, but for Martech M, we focused on the 4 criteria that I have shown. So it's not covered right now in its current state. Mm.
Thank you. But if it's once on the market, you may add more scores, more indicators. But first of all, you concentrate on the basic ones.
Yeah, that depends a little bit on what you need to take into account. Yeah, I see more urgent problems right now for the product design. When you think of a product designer, when you want to have more sustainable products, the product designer needs to make a choice. So he needs to stick to materials that provide the sustainability. So the choice of materials is limited. Also, the choice of joining techniques is limited when you want to have these things then separate. We want to separate the materials at the end. And so the limits of the product designer are the choices are limited for the product designer. And so the final product could cost more. Yeah, it could have lower performance. So there are a few disadvantages. And that could happen when you make these products more sustainable. I see a more urgent thing in that to incorporate such designs into a circular business models of companies, because apart from that, when you cannot make sure that you profit from the sustainable designs as a company, yeah, not just making your product better to separate and then as recycler produce material, high quality material out of that your competitors could also use, then you would have absolutely no incentive to do so. And so far, I think the first step should be to incorporate that and then head for circular business models first.
Very interesting. Thank you for your answer. Ludovine, you want connect to this?
Well, yes, and I wanted to thank the colleagues for their excellent presentations. I know most people are not quite as nerdy about this as I am, but you may remember that when the CRM Act was in discussion, one of the biggest differences between the version from the Commission and the Council and the version that came from the Parliament was exactly this: the increased requirements that the Parliament tried to put in the CRM Act for recyclability of products and, even across value chains, for resource efficiency. So designing not just the product, but designing operations to maximize product use. All of this was removed at the end of the negotiation and didn't make it into the CRM Act. So I think what's interesting here is 2 things. We clearly see that the representatives of the people are very keen to push this cross-boundary expectation, but European industry is not really adhering or accepting this kind of new pressure, exactly in the same way that European industry continues to struggle with the notion that responsible sourcing is also smart sourcing, is also resilient sourcing. And we continue to import massively from systemic rivals. So I think there is now a real conversation that needs to happen between a society that's trying to push these expectations that Sophie was mentioning, and frankly, an industrial sector that designs for price first, performance second, and for its bottom line first and foremost. And that's fine, I understand. That's the way their shareholders and capitalism works. As Europeans, we now need to think, how about tomorrow's bottom line? So the conversation here is huge. So thank you, Lorenz, for pointing that out.
May I add a little
Of course.
point? Just a little
Please.
point. I see the situation is not that dire, let's say, because when I speak of circular business model, there are already some established. So you have take back systems, you have systems where the companies remanufacture their own products and the like. And so far, you see also in the automobile industry, they have already contracts established with recycling companies because they need to make sure what happens to their products at the end of life. So we have already a system established where you can start from. So I see that not that dire, but what you need to have is to foster these systems, to push these systems so that you see more of that, so that makes a difference because they are rather small, let's say, at the moment. Yeah.
Yeah. In platinum group metals, this is something that is now established. And the huge recycle rates that we saw in one of the slides come from a business model where the metal continues to belong to the same person across application, same company across application. This is a complete shift in our super specialist economic design. So
Okay, let me connect to what you just said. There's a shift. You mentioned earlier, Ludivine, that there was kind of a blind spot, and it's still the mineral agenda is not really on the top level. It is fragmented, and there's missing a vision. And although it's now clear that we need these critical materials for defense, for aerospace, for our new green technologies, still it's not really going in the right direction, as you showed a little bit. And you put the point on missing funding. So and I want to highlight this gap of funding instruments. I think mining and mineral projects are very difficult to assess the risk. Why is it? And so it's difficult to get credits. And so how can this problem be solved, that we have more mining activities soon in Europe, for example?
Thanks for this question. So I'm going to caveat right away by saying I do work in minerals. And no, I'm not asking for a big blank check from the European taxpayer or from European private capital. The reason I think funding is key to this equation is that we have an input problem and an output problem. Mineral operations are very difficult to fund, so to actually, develop and expand, but also responsible mineral operations, geostrategically aligned mineral operations, whether they're mining, processing, manufacturing, they also have a market problem, an output problem. The additional cost, the repositioning with sometimes extremely powerful buyers. You have both sides of the equation, the money going in and the product going out, and not necessarily a market for either one. So the reason I think European mineral funding would be a game changer is that you need to work on markets, but this is going to take time because entire industrial sectors need to change their habits, change their relationship to their value chain, change even how they themselves are funded, how they invest. This takes time, whereas having an input of European capital into mineral production, both in the EU and outside the EU, very strategically, would effectively create the right to access production, would create more control over production, and therefore also support the change in procurement practices, the evolution of that practice. Just to be clear, I do think that the goal here is not public sector funding, because it should always be small. It should always do the most difficult step so that others can follow. For me, the game changer is European private capital reallocating to all of the strategic priorities. This is in the competitiveness compass. This is what President von der Leyen was referring to when she said we need trillions of European savings working for Europeans on more renewables, on upgrading our grids, on reindustrialization, on defense. All of these priorities need European money. And as you know, money talks. So I think in that context, we should not forget minerals as a pillar. And I think we should all be watching what the Competitiveness Fund is doing. There's a new report just came out, and we could very well see more strategic thinking and allocation in the Competitiveness Fund, which would be very positive.
Thank you, Ludwig. I would like to take a question from the chat from Anja Köhne. She appreciates your comment. Even though I start in the middle of her question, even though there are great people in industry, as Tom said, the dominant mindset is not up to current geopolitics nor the climate change, especially at high levels. How can this mind shift in the industry be achieved, which is, after all, in the enlightened existential self-interest of industry? Well, it sounds a little bit philosophy-alike. May you give us a concise answer, Ludwig? And yeah,
certainly. I think we are everywhere. We save money, therefore we direct how our savings are used. We vote, therefore we direct how our policy shapers position. We are the suppliers, the contractors, the service providers of this very industry. We are also the buyers of its product. I think one of the key points that both Tom and Sophie and Lorenzo raised is the fact that we continue to present the geoeconomic, the energy, the minerals transition as something where, you know, we can push some goals in the long term. I think what we need to accept now collectively is that, again, if you want long-term goals to be realized, some of them need immediate action. And I would really refer you to the concept, I think Tom alluded to this, resilience comes from responsibility. It is not a cost, it is an investment in a different type of return. It's also, I think, up to all of us to redefine what that means. And yes, do we design for recyclability? No, because we're not forced. Will it be a key economic driver in the future? Absolutely. It's almost it's almost not in doubt.
okay. Maybe the virgin materials need to be much more expensive than they are right now, and even more difficult to get. Maybe then all of a sudden there might be a quick change. But I don't want to pray that this will happen, but sometimes high prices are initiating some change. So I'm bicycling lately a lot. Okay. I would come back one more time to our policy briefing and show a little bit of a key result and address this question to Lorenzo. Lorenzo, you mentioned the indicators, and maybe also funding is lacking because it's, as I said, probably difficult to assess the risks of a mining project and the outcomes and the profits. And here comes these indicators for resource management, material footprint, which is well known. And now, Lorenzo, you compared a material footprint to total material requirement. Can you summarize quite sharply why the indicator of TMR, total material requirement, is a good assistant to material footprint, which is not now the standard, but this is not enough in our perspective?
Thanks, Anja. Yeah, sure. So as you heard before, two indicators. The material footprint is really good to give us an idea of how much material is used to produce, for example, a product. That's what we're looking at, product production, so PtX production in our case. And can be very good in assessing how much material is needed, but it doesn't tell us much about the environmental repercussions of using these materials. That's why the TMA gives us a much better information about what's going to be the impact on the environment, because you can imagine material footprint can be, if you take two technologies in comparison, can be that one is a lower material footprint, but the material that is needed for it's much more, it's anyway deeper or present in other kind of reservoirs that so have a much higher impact on the environment. Or maybe this material is to be further elaborated and analyzed and so on. So the TMA really well complement, in our view, the material footprint. And that's why the material footprint, if you want to also to look at the sustainability of a product, is not enough. We also have to look at the environmental repercussions. And TMA gives us really an idea of what's going to be the impact on the environment. But as a second answer to your question, why the material footprint could be also not enough, because we're talking a lot about the criticality of materials. So again, the material footprint can give us an idea of how much material is needed, but doesn't tell us anything about how much critical is this material. So if we look now more the economic part, or the supply chain, it doesn't mean that if we look at PtX products, that if a PtX product is a lower MF, doesn't really mean that it's easy to be produced, or from an economical perspective and also supply or the value chain perspective. And that's why in this case, other indicator would be needed, or other criticality assessment, like for example, the one defined in the CRMA. But also here, other indicators could be used, like maybe some of you know other indicators like the ADP, the beauty depletion potential indicator, and others. But that goes a little bit beyond the discussion of today. But the MF, so it's a very, very good indicator, but it's not enough for all the purposes. So at this point, we propose the two, MF and the TMA, as two important indicators, one for the aggregated overall material requirement, and the other one for the environmental repercussions and impact.
Mhm. Thank you very much, Lorenzo. And I also would like to bring in Sophie again. Sophie, in our briefing, we observed that the supply side is always in the focus of European policy, but the demand side is kind of not so much in the focus yet. So how could we make secondary materials more attractive? You mentioned already the standardization for the criteria. Can you kind of elaborate a little bit this aspect?
Think, like I said, I think the harmonization of end of waste criteria is like really a key lever, just because it brings this market certainty, and it enhances the cross-border trade and makes use of the EU's single market, which is frankly a really just the strength of the EU, if we can say so. I also think what Ludovin kind of touched upon is like money is key, and maybe they need to be forced. So I think like one instrument that's widely used and discussed is like recycled content quotas. So they are per definition designed to enhance demand. And I think we've seen in the EU battery regulation how that could be done. I think there's also a lot of improvement there. But I think it's worth examining to see if that could be extended to other critical raw materials like those that are needed for the energy transition. But of course, I'm going to be a little bit of political answer here, but I think that can only work if we bridge the demand and supply side. And that kind of brings us back again to this whole question of infrastructure and product design, like Tom talked about, and EPR, extended producer responsibility, sorry. So I think really only if we manage to bring all of those together, then we'll manage to enhance the secondary raw material market and supply and strengthen.
Okay, thank you so much. We have 5 minutes more or less left. I would like to come to slowly to an end. Here's a question that I would like to address to all of you four. The supply of these strategic and critical raw materials is in the focus because it's so important for our industries, for our economic well-being, and now all these geopolitical tensions and disruptions that make us very nervous. And the supply can be met by imports, by domestic production, and of course by more sustainable resource management. And my observation is that this sustainable resource management is kind of like a stepchild. And this is my observation, and like circularity recycling. Why is it so difficult? Not for copper, but for other elements. Why is it so difficult? Or, for example, to save materials, to make less with materials. Why is this so difficult? And is this in the system inherent because we need to grow and we have an we focus only on growth rather than on becoming more smart and small? Nobody is staring.
Anya, I think you will get us in trouble with all the engineers because they will give you some very precise answers about substitution of materials and costs and, efficiency of the manufacturing process and the product. I want to offer two sort of not responses, but additional elements very quickly. The first one is that we have had over the last 4 or 5 decades an economic principle of super specialization. A company went from being very integrated, doing multiple things, particularly in Western economies, to being super specialized, and everything that was less profitable or presented some challenge was removed to another company, sometimes to another region. So this principle of super specialization is something that delivered huge returns, huge growth, and huge wealth. It is perhaps no longer suited to the future, but it takes time to adapt to this. And I think we need to recognize that this knowledge of how to have vertical integration with profitability is something that we have not cultivated. It is a strength of China, but it's also a strength of Korea. It's also a strength of Japan. We need to work with the real allies like Korea, like Japan, and others to regain the strength and to build with them these integrated systems. And the second thing I would say before Tom can bring in the real answer is that over the last 30 years, as we super specialized, we also developed an externalization of costs, risks, impact. And we pretended that they did not exist because we were not dealing with them. And that includes the hugely complex environmental and physical impacts that Lorenzo was describing for us. Again, reintegrating that into the way we do business will be a huge effort. So again, I think we need to focus on our industry and exercise every opportunity for leverage, but also support. So that's why I appreciate what Tom is doing in helping to rethink how we value these things.
That I can just underline what you've said. What we've often see that is in companies that have their own products that never had to thought that hard about it. That just design their products and performance and price is key, and everything else is second. And I've experienced a lot of let's say products over my time as a researcher back then when I developed recycling processes for such waste materials, and I've seen the product was definitely there was no attention paid to what happened at the end of life. I've even seen products that crushed the business case of recycling of recyclers because they've changed certain materials that were important to the recycler but not important to the producer. And I've seen a lot of such things right now. I see that that several companies are thinking about it. We see some uh, change dot, but it's still slow. And sometimes you also see that they think about strategy, what could be the strategy, but they are not right there right now. Um, when I think of change of mindset, you see a few things that already also went through the media. For instance, Volkswagen, they are changing. In my home federal state of Saxony, they announced that they want to change. They want to have new disassembly lines, for instance, to recover components from cars, and that could be something where you say, okay, they are thinking about regaining materials and components and in order to implement them further into their products. So I see as a main change, but of course I have the feeling that's still far too little right now. And I'm thinking about, could we foster that a bit? Yeah, through your economy, because I also have seen some parts where I say, okay, we're thinking about recycling content in products, yeah, but recycling content and products means the material should come somewhere. And when you do not have high quality material available, then where should it come from? Yeah, we import that too, maybe. Or it's just not
Okay.
available. Yeah.
Thank you.
So,
Yeah.
mm,
May I rebound on what Tom was saying and simultaneously respond very quickly to our colleague Eberhard, who asks, how do we weigh the transition and defense? And I would say, let's be smarter than that, Eberhard, because defense and the military economy is actually a space where price is not the only consideration, where the stakes define other behavior. So I'm almost thinking, let us think through what can defense demand unlock in mineral value chains that will be also useful to transition uses. And secondly, I would actually say, let's also look at how our governments are framing defense, but more widely security. When Germany rethought its defense and security spending, it also included strategic infrastructure, key parts for energy resilience. Let us then think how we can make our technologies and the transition pillars that are vital to the long-term future fit into a more security-minded approach. Not defense, security. And I think this could actually help us, because this is where we can overcome this issue that Sophie was pointing out repeatedly. You need to have a market to sell product. So let's try and use a market we may not like very much because it's very terrifying, but maybe that's where we get some security drives resilience and we use it for responsibility.
Very interesting. Thank you so much, Ludovine, and also to answering this last question. I was already skipping, but now you picked it up. Thank you so much. And I have to come to an end, and my team wants me to share a last slide. So please let me show you again my presentation, and I want to highlight the next PtX Lab Talk in June. No, first of all, on our website, you find our briefing for download. It's today on the website from today on. And our next lab talk in June will focus on agri-photovoltaics, agri-PV, and green hydrogen. And here's the call for you. If you know or you are yourself some stakeholders from agriculture, from businesses of photovoltaic in Germany in this area, you may contact our colleague Michael. You see his contacts here, and this event will also a hybrid event. So we have a PtX Lab Talk as a first part, and the second part we have kind of a workshop here on how to boost agri-PV in our region of Lausitz or Lusatia. And last but not least, if you are now you have now the spirit of working in natural resource management or critical raw materials field, we have a job vacancy in this field on our webpage. So with this, I would like to end. I would like to a big, huge thank for our speakers for the brilliant insight you shared with us. And I hope I see some of the audience again in the next lab talks. And yeah, I hope it was inspiring for you. And you can every time contact us via our website. Thank you so much, and have a good afternoon. Bye-bye.